Guys, welcome back to my channel. Today we're gonna examine a few things about lights and this type of light. You see, it's a bulb. It shows this is green, this is red. Okay, these are LEDs. What does the word LED mean actually? LED means light emitting diode. Light emitting diode. Diode. D-I-O-D-E. Diode. So, how does it work, or what is it actually? Basically, it's for emitting light. Maybe I should show you a bit of it. I don't have something here. Maybe I'll push this closer. Sorry guys, I want to show you something here. I mean, you know what's light? Is it something new to you? You know it. You use it every day. Yeah, so it's something like this. See, it's lighting. This is blue. Yeah, it looks blue, and if I disengage here, light is on. I mean, you know what this is. So I'm not going to talk about this. Let's first of all see this diagram. I don't know, the problem is that this diagram doesn't show so clearly when I done on the book, but basically it's about B type and any type. N type stands for electrons. N type stands for electrons, and B type stands for holes. If I can draw a small sketch here just to illustrate. Or maybe I'm doing the wrong way. This should be holes and this should be electrons. Just a few. And I say this B type, and this I say is N type. N type. Let me write something. I'll just show you in a minute, guys, what I'm talking about. These are holes and those are electrons. Maybe you should write electrons. You know what electrons are? Electricity cannot flow. What is called electricity means electrons, the small particles of an atom. An atom is made of what? Nucleus, protons, and electrons. Electrons is what gives the charges. Okay, so these are, if you don't know how electrons looks like, the spelling this electron. Okay, and these are holes. It's called holes, possibly charged or protons. So there are holes here. I'm not going to go to very technical part of it, but there are holes here, and this electron move to fill these holes, and here is the place where they combine here. This angle is where they combine. So here we have positive and you have negative. So you can see I've done it, positive, negative. Holes is positive and this is negative. So they combine, and when this happens, the Fermi level, I'm not gonna draw the Fermi level. The Fermi level looks like, I have to wrap this one off. Okay, when they combine, light is emitted in the process. Light is emitted in the process. Guys, just hold on a minute. So see this diagram? It describes how these LEDs work. Holes and electrons moving to feed the holes. And then we have another thing. It's not good in drawing. I'll show you in a minute. Yeah. Okay. So we have in light here, and we have a wave-like stuff moving, and we have the combination taking place. I'm gonna show you. Just don't worry. As I always tell you, be happy. So these are electrons, and the holes and the electrons combining. So I'm just trying to illustrate to you this electron holes and electrons combining, and then when they combine, the light, this light wave goes this way, and this is what we call Fermi level. Fermi level, and we have band gap, we have valency, this type of thing. Here the combination takes place and light is emitted this way. These are just diagrams to illustrate what really happens in a diode. This is a LED. So what happens when a current passes through an LED? This thing I've just shown you. Okay, this is a diffuser. I'll show you that later. Maybe this video or the next video, if you stay tuned, I'll show you the technical part of it, how it works. So when current passes through a LED, the electrons recombine with holes emitting light in the process. The holes I've just shown you and the electrons I've shown you, they combine and they give light in the process. So LEDs allow current to flow in the forward direction and blocks the current from flowing in the reverse direction. So light emitting diodes are heavily doped PN junction. I hope you know what doping is. When an electric current passes through a microchip which illuminates the tiny light sources we call LEDs, and the result is visible light. Maybe I'm gonna see this stuff. This is a diffuser. This thing is called a diffuser, so I'm gonna remove it. So I've removed it. You can see what is inside. Now I'm talking about this thing stuff. These are LEDs. These are the things that emit light. Those ones you're seeing. I think you know, are familiar with it. Maybe you are keen enough to observe what is around you. And maybe this is a holder. I don't want to remove it because putting it back will be a problem. In the second video I'll do about this, I'll remove everything. So you have to stay tuned to see what happens. I'm going to show you a bit, just a bit. You see, light is come off those things. You see, they're lighting up. See, they are gone off. Repeat. See how they're glowing, illuminated. The illuminate is gone. And these are the things. LEDs are just those ones, and if you open that below, you see there is a small motherboard where we have capacitors, yeah, resistors maybe, and other there to regulate the currents, yeah, act as regulators. So let's go on. The two primary materials used. What is used to make these LEDs? First of all, I'm giving the formal introduction about this, then we can do the dismantling of this, called the disassembly, now on the next video. So what are the materials used to make LEDs, to make these things? This is a diffuser I've just removed, okay, to make this. You can see this anode, cathode here, anode, cathode. So the material used are aluminium, gallium in the periodic table, yeah, the elements. The material used are aluminium, gallium, indium phosphide, alloys. Alloys, you know, is an alloy is a mixture of something, and indium, gallium nitride alloys. Those are the material used to make LEDs. Now you can see a diagram. If I can draw it, actually it's quite complex, but it looks like this. You can see it, and if I'll use this to illustrate to you, because drawing it's a big deal. Here we have epoxy lens. This is the diffuser case. Inside here there's a wired band, refractive cavities there. Where is that thing? Here inside. We're talking about this side. I just shown you right how light goes on, reflection and so on. And we have a semiconductor die and wheels. It's just the way it's made. Flat spot, cathode, anode and stuff like that. Light emitting diode. Okay, good. So the materials used to make this, I've told you, aluminium, gallium, indium phosphide alloys, and indium gallium nitride alloys. So aluminium alloys are used to obtain red, which is like this one, for example, orange, I don't have orange, and yellow, I don't have yellow. That's aluminium. And indium alloys are used to get green, which is this one. Blue I don't have, and white I don't have. So these are how these materials are used. So you'll find that LEDs have different colors. They are made from different materials. And the light, of course, this one will come green, this will come red, yellow, white. Yeah. So these are things that you are having every day in your bathroom, your kitchen, and that's the physics behind it. So maybe I want to show you one thing, and we just end it up here, and next time we'll do the thorough investigation of what really lies inside this stuff. Okay. So I've just shown you, this is a diffuser. I've removed it, and this is a case. I can put this, let me see whether I can just do it. It's very difficult, by the way. See, I've removed it, it's engaged in this. This is just a holder. And then let me see whether it's possible to insert the red one. It's quite some job work to do, and I have to be careful not to destroy this thing. It's quite difficult to put it, and I can really damage the holder. Yeah, it seems like it has gone. Yeah, put this to the holder, and this is a dielectric, so I will not get any shock here. So let me put this, and you see what comes of this. You are all familiar with these things. You're using them every day. See, this is red now, and if I can open it, I can open the diffuser. Not quite easy. Maybe I'd have to break this to open it. It's really held very hard here. Some of these things you have to crack here to open them. I have to crack it to open, but it's just something looks the same like this one. What is that thing? Yeah, this one I just already opened. It looks the same like this, but it emits red. So below this, let me try to see whether I can open it below. Let's see. But I'm not going to do everything about it now, because I have the second video coming that is going to show you this stuff. You know, actually it's soldered here. There are two wires which are holding this thing here, and the current, the input comes through here, right? And they illuminate these LEDs. So I told you what the LEDs are: light emitting diodes. Diodes are this kind of thing that allow current to flow in one direction, not the other. So I'm trying to open it, but I don't want to break it actually. It's totally held tight, and this looks like a Jeep. some small microchip is there. You see, if I pull it hard, then it will just disengage from the point where it is soldered. Yeah, actually it's cracking. It's difficult to open it, I don't know. I don't want to break it. So I just try to open, you see. Actually I've broken one side of it. I was fearing that it's going to happen, and it has happened. So this one has just come out. So now this is no longer useful. It is shouldered back. That will entail a lot of work because you have to open this case. But anyways, for learning, so yeah, it has just come out from there. I pull it. This is what I'm talking about. Yeah. And this is the capacitance. Capacitance takes place here. And the half length, maybe I'll see how much of it. The capacitance is the C2. There is what is that? I'm trying to read 104. That's DH. D for diode. I think there's capacitance 1. Okay. Yeah, it just came out of that place, and there's this metal that's holding. I think this is what conducts the power when you put inside the holder here. Sorry, I think that my LED is damaged totally. And there's the motherboard. This is a motherboard actually. Maybe I should just remove it totally now because it's damaged. This is a motherboard. This is how tiny it looks. Oh baby, you are damaged, baby. It has to be repaired, and I don't know what that entails. Anyway, so it resides inside this thing, which is also dielectric, I guess. Should I disengage all of it? Yeah, because this is soldered here, so you have to burn it here to bring it out. So guys, this LED bulbs works like that, and this what is inside these cases, which you see is a diffuser. Inside the diffuser you have this thing which I've just removed, and you can see that's a capacitor. Capacitance is there, and other things are there, but I can't see much of this actually. There must be some kind of resistance there, although it's not labeled. And maybe in the next video I'll take this thing apart. And we'll see what is inside. But for today, we're gonna end it here. Yeah, I'll do this later. Okay guys, thanks for watching. Please subscribe to my channel. Stay tuned as we try to stay learned about these things that are around us. And there's quite a lot to come. Thanks for today. See you again. Subscribe to my channel, like, share, and subscribe. And I even wonder sometimes whether there's anybody watching me, because I always say subscribe, but I don't see anybody subscribing, but I see views. So how do you view something and you don't subscribe to it? Why do you view it? I'm not saying you shouldn't view, but why don't you subscribe? Share it with your friends. Let them also see this. Okay guys, bye for now. See you later. Bye.